Good afternoon. Today we are here to start about our first topic, that is geometric design of rural highway. Now first of all, what is the geometric design? Geometric design is all the visible component that you see on any of the highway. The geometric design components that are designed are on the basis of IRC 73 1980. So all the parameters of the geometric design are to be taken into the consideration on the basis of IRC 73 1980. Now the various components that are to be included in this geometric design is, the very first is side distance. The second one is intersection elements. Then after, horizontal alignment, and lastly vertical alignment. So today we will begin with the topic of side distance. There are three main types of side distance when we consider in the geometric design of a rural highway. The first one is stopping side distance, which is also termed as SSD. The second term is overtaking side distance, which is termed as OSD. And lastly, intermediate side distance, which is known as ISD. Now I will begin with the first topic, that is stopping side distance. Now suppose you are traveling on a straight road. Now the driver will be traveling in a car. The driver's eye will be at a certain distance above the carriage. And suppose there is an obstruction at a certain distance on the road. According to the IRC, this standard height should be 1.2 meter. As well, the obstruction height should be 0.15 meter. Now while you are traveling on this road, due to this sudden obstruction that you see on the road, you need some limited distance, which is known as stopping side distance, so that this distance is the safe distance that you should maintain, or the time when you should apply the brake before occurrence of the collision. Now this SSD is divided into two major parts. The first part is known as leg distance, and the second part is known as braking distance. Now I will explain you both the parameters, that are leg distance and braking distance. Now first of all, what is leg distance? While you are traveling on a car, you see an obstruction on the road. The time period for which you realize that you need to apply the brake, this time is used, and the distance traveled along this time is known as leg distance. So this leg distance will be, as we know as, distance is equal to velocity into time. So the time that you apply before the application of brake, here it is known as reaction time. Now as per IRC, this reaction time is ideally taken as 2.5 second, and this 2.5 second is the 90th percentile reaction time. Now what is 90th percentile reaction time? Now if you carry out a survey for the various people, for example consider 100 people, and you find the reaction time for each individual. Now when you plot a graph between the reaction time and cumulative frequency, you will get this kind of certain type of graph, right? Now consider the 90th percentile frequency, that is cumulative frequency. Take along this curve, extend it downwards. So this value that the IRC has obtained is 2.5 seconds. So what is lag distance? Lag distance is just the distance that you travel while you take the reaction time before the application of brake. So this is the reaction lag distance, which is termed as V into T, where the unit of T is in seconds. As I said, it is 2.5 seconds, and V is in meter per second. So the total distance that you will get is in terms of meter, right? Now further, I will explain you the braking distance. Now, after this point, you have realized that it is the high time to application of the brake. So from here, you apply the brakes. So this braking distance is the work done, and the work done is the kinetic work done. So it will be half mv square. Now, as we know that work is equal to force into displacement. This L is the braking distance L. That is the distance travelled after the application of brake. And here it is half mv square. Now what is force? The force applied here is friction force. So we will write as F is equal to small f into W into L, where F is equal to coefficient of friction in the longitudinal direction. Longitudinal direction means the direction of travel along the road along which you are traveling. So this is coefficient of friction, and this is the weight of the vehicle. L is the distance travel along this. So it is equal to half mv square. Now again we write W, that is weight, is equal to mass into gravitational force. Now cancelling out this term and making L as the subject of this equation, we will get L is equal to v square upon 2g f. So this is the distance that you consider for the braking distance. So the total SSD will be equal to lag distance plus braking distance. So we will write as Vt plus v square upon 2g. This is the ideal equation that we consider for the SSD, that is stopping side distance. Now there are certain things that we consider in the SSD. For this particular equation, we consider that the friction value or the braking efficiency is considered as to be 100%. So now, if you are given that the braking efficiency is not 100%, it is some particular value that is considered as eta, then the equation becomes Vt plus v square upon 2gf into eta, where eta is the braking efficiency. So now your modified equation for SSD is equal to Et plus v square by 2gf into eta. Now, one another term that we will take into consideration is the slope, that is longitudinal slope. The longitudinal slope can be of two types. Either it is increasing gradient or it is decreasing gradient. Now when you consider as the increasing gradient, let us consider this value as theta, or we can consider it as tan theta. But theta is very small value, so we can consider tan theta is nearly equal to theta, or sometimes we term as n percentage, that is percentage of slope. So in this case, it will directly affect the friction rate. Now for this longitudinal increasing gradient, we will take as plus n value, and for the decreasing gradient, we will take it as minus value. So again, while you consider the gradient value, you need to modify equation with Vt plus V square by 2gf into eta. Remember, this efficiency value, braking efficiency value, will be directly multiplied with the f value, plus or minus n value in terms of percentage. The main thing that you need to remember in this equation is both the v's are in terms of meter per second. T is in terms of seconds. Now, even IRC has defined this coefficient of friction value, and this value is between 0.35 to 0.4. If in the exam you are not given a specific value, you can apply the value as 0.35 or 0.4, and you can check the corresponding nearest value of the answer and take it. Now, while considering the lag distance, the lag distance basically works on the PIEV theory. The P is perception. The perception is the time for which you perceive that something is happening on this particular road. The next is intellection. This is the time when you receive the signal to the brain and you need to realize that what is to be done now. Right? Now the third parameter is emotion. Emotion varies on the various type of this reaction time. For example, you are in fear, or you are in anger, or etc. Consider any of the parameters. For all the parameters, it directly affect the reaction time of the driver. And the last is evaluation. This is a time when you determine for the application of brakes. So all the four parameters are very crucial in determining your reaction time, which I would again suggest it is 2.5 second as per the IRC. Right? Now, all the parameters or all the side distance that I said you, that is a standard equation. SSD is equal to Vt plus V square by 2gf eta plus or minus n. This value is the minimum value for SSD on any particular road. Now, depending on the various cases, the SSD value differs. For example, there is a single lane road, there is an obstruction here, and there is traffic flow only in a single direction. In this case, the SSD will be equal to directly is equal to L. So, minimum SSD is equal to only SSD that you will derive from this equation. Now, in the second case, consider a single lane road, but the traffic is in the both the direction. Suppose the obstruction is somewhere here. So now, in this particular case, you need the SSD in this particular direction as well as in this particular direction. So you will get L on this direction and L on this direction. So the total SSD will be equal to 2L. So in this particular case, minimum SSD is equal to twice the safe side distance that we derive from the above equation. In the last case that we will discuss today, is on a two-lane road and two-way directional traffic. In two-lane road, the roads are divided based on a particular median. So in this particular case, even if there is an obstruction on this way or in this way, the total side distance you need is only to be L. So in two-lane, minimum SSD EB is equal to SSD. So in one particular case, that is single way, single lane, two-way traffic. Only in this particular case, you need to consider minimum SSD is equal to twice the